All right, let's take a look at this engineering application. You've done one like this before, earlier, probably the exact same question, but let's take a look. It says an engineer suggests using a cable attached to the top of the Leaning Tower of Pisa to a point 44 meters from the base. And so if we look at where that's located, that would be this cable here, going from the top of the Leaning Tower of Pisa to the ground, and notice it's 44 meters from the base. Okay, how long is this cable? Okay, it says to round length to the nearest tenth. It also says, notice you're given SAS, you have an angle and two sides on each side of it. Which law of triangles are you going to use to solve? So hopefully you look in your notes, and when you have SAS, the law we use is the law of cosines. Okay, cosines has a lot of numbers in it, so then you want to be really careful. Remember that when we label our triangles, here's capital B, lowercase b would be directly across the figure from it. Capital A, there's our angle A, so side A would be directly across from it, and here's our angle C, capital C, so the side C would be directly across from that. We want to write out our law of cosines here. So we are looking for, what are we looking for? We want to know the length of this cable. That's our little b. So we know over here we're going to have our b squared equal to, that should equal the other two sides squared. So our little a squared plus our little c squared. And I'm just following the formula. Hopefully you should have it written in your notes, the law of cosines. So minus 2 times those other two sides multiplied together, so a and c, and then times the cosine of our angle that's across from the side here. So that would be our capital B, our angle that we know. Okay, we continue from here. Let's fill in the information that we know. Do we know our little b? No, that's what we're trying to find. Do we know little a? Yes, little a is that side that's 52. Plus little c is the side that's 44 squared minus 2 times those two sides multiplied together, 52 and 44, and then times the cosine of our angle, and this time we know our angle, it's 110. Now we take out our calculator. We're going to do a lot of calculating here, and we calculate each of these things. Again, I don't know b squared, but I can square 52. That gives me 2,704 plus 44, I can square also. It's 1,936. And now I multiply these together. Now again, in your calculator, when you pull out your calculator, I would start with the cosine part. Notice those four things are all multiplied together. So first I'm going to start with the cosine of 110 times 44 times 52 times negative 2. Okay, I get 1,565, I believe, 0.08. Okay, now notice I just have a set of numbers here. I can add those together. I still have just b squared on this side. Over here I can add those numbers together. So 2,704 plus 1,936 plus 1,565.08. Now just a note, sometimes this will be negative and sometimes it will be positive. Just depends on the size of your angle. So just calculate carefully there. This time it came out positive. Okay, when we add those together, we get 6,205.08. I still need to solve for b. The only thing I have left to do is get rid of that squared. How do you get rid of a squared? You do the opposite of squaring, which is to take the square root. So b is going to be equal to the square root of that number. So I take the square root of 6,205.08, and I get 78.8 approximately when I round. So the length of that cord is 78.8 meters. Okay, here we have another example. It says rescue teams at 2 heliports A and B So those are where the helicopters are coming from. Receive word of a fire at F. What is the measure of the angle AFB? Now, where is that angle located? Well, to find the location, it's the middle letter in the angle's name. So it's this angle right here at F, AFB. Says hint, you're given ASA, so select the correct law. Now, normally we would go, okay, well, with ASA, we are supposed to use the law of sines if you have two angles. But let's take a look at this. What are we trying to find? We're trying to find the measure of this angle. We're not trying to find any of these other sides. So we could actually make this much easier on ourselves. We have two of the three angles in the triangle, so we really don't even need to use the law of sines or the law of cosines here. All we have to do is say, well, we know that the three angles in a triangle add to be 180. So whatever angle F is, plus 48 plus 42, together those should equal 180. Again, that's because they're the three angles in a triangle. I'm going to go ahead and add my 48 and 42 together. Now I get 90, so F plus 90 equals 180, and then subtract 90 from both sides. And I get F is a 90-degree angle. Doesn't look like that, it's close. Okay. Right, so this one I really didn't even have to use the law of sines or cosines because I had two of the three angles in the triangle. If they had asked me what the length of one of these sides were, I would have had to use the law of sines to find it.